Point 1, graph quadratic functions in standard form. All right, so first problem says to copy and complete the table of values for the function. So they give us the function y is equal to negative 3x squared. And then the table, they give us the x values, and we have to figure out the y values that go in it. So they go from negative 2 to 2. So if I plug in negative 2 for x, what do I get? Negative 12. Because negative 2 squared would be 4, and then times negative 3 would be negative 12. Negative 1, negative 3, 0, 1, negative 3, 2, negative 12. All right, so if the method that I'm about to teach you, you're like, I'm super confused, I have no idea how to graph this and whatever, then this is always a method that will work, but this takes much longer than the other method, okay? Now, the next problem, say to graph the function and then to compare it with the graph of y is equal to x squared. We're not doing the compare part, but we're going to go ahead and get in the habit of everyone that we graph, we have to find the vertex and the axis of symmetry, okay? So you're going to have to write that at a minimum. Even if you do a table, you're going to have to find what those values are. So number 8, y is equal to 5x squared. So my axis of symmetry is occurring, so when I do AOS for axis of symmetry, is at negative b over 2a. This also happens to give you the x-coordinate of your vertex. Okay, the x-coordinate of your vertex is the same as your axis of symmetry. The other thing to know about the axis of symmetry is that it's always an equation of a line because it's graphing a line. It's just a dotted line. Oh, thank you. It's just a dotted line, okay, that gives you that. So, in this situation, okay, you should have had in your notes somewhere, it should have been written, but normally we have the form ax squared plus bx plus c. So, b is coming from this middle term, which I don't have in this situation. Okay, and c is from the last term, which I also don't have in this situation. So what would that tell you that my axis of symmetry is going to be? If I just have 0 for both of those things. 0. So my axis of symmetry is that x is equal to 0. And then my vertex, the first point is 0. The second point, we are going to plug in 0 for x, and we get 0. So this one isn't shifted anywhere. It's just at the parent function. The only thing that's different is the 5 in front. So to graph this, we have something like this. So I've got an axis of symmetry at x equals 0, and so we will have a dotted line, okay, and label it AOS for axis of symmetry. So I have to clearly see it or I take points off. Okay? Axis of symmetry, your vertex needs to also be labeled. Okay, so my vertex here is at 0, 0, or well, I say labeled. It needs to clearly have a point at the vertex. Now, I need to figure out how to graph this parabola because it's a squared function, so it's going to be a parabola. So I'm going to pick another x value that's not 0 to get a point. Okay, so I'm going to pick 1 because that's the easiest. So when x is equal to 1, y is equal to what? 5. So 1 and 5 is going to be my next point. So 1, 2, 3, 4, 5. So here I have 1. Now, what the axis of symmetry allows us to do is that where something is on one side, it also is on the other side, okay? So I have the other point is going to be at -1 and 5, and then I just connect the dots here, and it's rounded, not pointed. Don't do this. Don't be like, this is my parabola. That would be an absolute value, not a parabola, okay? Make sure it's rounded. Any questions about that one? Because this is like the most basic type. Okay. We'll do one more of the easier type, and then we'll go into the ones where we actually have to do some stuff. 10. We've got y is equal to -x squared. So anytime you have a negative in front of your x squared term, that means that it's reflected, okay, which means that it opens down. So this one opened up. This one down here is going to end up opening down like this. Okay, it flips it over the axis. So it's an upside down U. So, again, I don't have a B or a C term. So what does that tell me is going to be the case for my axis of symmetry?
0.
Okay, so my axis of symmetry is going to be at x equals 0 again. And then my vertex, if I plug in 0 for x, I would get what?
0.
So my vertex in this case again is going to be at 0, 0. So I'm going to set up my graph. So I have my axis of symmetry I'm going to label here. And if you're just using a pencil and not like another color, then just extend the dots a little bit past on the top and the bottom, and then again just label it, and that way it'll be clear of where it is. Because if you're just doing pencil on top of pencil, it's going to be really hard to see. Once it's not on the axis, it'll be easier to see because it'll actually be a distinct line. But I've got my axis of symmetry labeled. My vertex is at 0, 0. Now I'm going to pick an x coordinate or an x value to plug in. So I always am going to pick the easiest one. If 0 is an option, I'm always going to pick that because obviously that makes a lot of things cancel. But in this case, I obviously already have 0. So I'm going to pick 1 because that's the next easiest number. So if I plug in 1 for x, what do I get? -1, because this is outside of the square, so it's not getting squared. So -1. So if I'm 1 away on this side, my axis of symmetry says that I'm going to also be 1 away on this side. And then I graph my parabola. Okay, and I'm not going to like get out and measure that it's like perfect, but that's approximately what it would look like.
You said the negative was outside what?
Like it's outside, so like the negative isn't getting squared. If it was this, then the negative would be getting squared. But it's just, since it's not in the parentheses, the squared is only going on the x itself. Because a lot of people end up getting it wrong. But if you had done that, you would have gotten a value that was up here. And if you had noted that it needed to go up and down, you would have realized that it was wrong. So that's why I tell you, the negative in front always means it's going to open down. There's no scenario in which there's going to be a negative in front and it opens up like this. It's always going to be flipped upside down.
Okay.
So you would realize that it's wrong when you go to graph it, and all of a sudden it's like this, and it should have been like this. All right, let's get into one that has something besides just the x squared term. So 14, y is equal to 4x squared plus 1. So I still don't have a b term, but I do have a c term now, okay? Which means that my axis of symmetry is still going to be at 0 because b is 0. So remember, a formula for axis of symmetry is minus b over 2a. And so I still have do not have a b term, so that's going to be 0. So my axis of symmetry for this one is still going to be at x equals 0. But my vertex now is going to be at 0, and then if I plug in 0 for x, what am I left with? 1. So 0, 1. So now when I graph this one, okay, this one's going to be opening up because it's positive. So then I have an axis of symmetry still at 0, so I'm just going to extend this and label it. But my vertex now is at 0, 1, so my vertex is now up here compared to where it's been being. So if I plug in 1 for x, what do I get? 5. So 1. So I come over to 1 and then up 5. And then axis of symmetry says what I have on one side, I also have on the other. So I have 1 over here as well. And then we just connect it. All right, I want to get to some that do not have an axis of symmetry at 0. So jump to 22. So the difference in these graphs pretty much or these instructions is the one just says to graph the function and compare, but we're not doing the compare part. But the next one say to graph the function and label the vertex and axis of symmetry, but I'm already asking you to do that. So that way we're just consistent across the board for every problem. It'll be the same. So 22, y is equal to 3x squared minus 6x plus 4. So I'm going to rewrite the formula just since now we actually have a need for it. So the axis of symmetry occurs where x is equal to minus b over 2a. So plugging stuff in, minus b, well, b is negative 6. That's going to become a positive 6. So 6 over 2 times a is 3. So that's also 6. So that's at 1. So my axis of symmetry is that x is equal to 1. So now I use that and I get my vertex. So my vertex is going to be at 1. And then when I plug in 1 up here, what do I get? 1. So my vertex is at 1, 1. So now when I go to graph this one, and we still are looking at the sign in front, so this one is going to open up. Okay, it's still positive. So I have, and this is one of those where people usually don't use, I mean, you're welcome to use graph paper, but people don't usually because it's not really, you're not like trying to find an intersecting point where you like really need it to be. So, axis of symmetry, x equals 1. So, see, when you do it here, you will graph or like label the whole, or like write the whole line down, dotted. So that I would be able to see with the pencil, but if it's on that y-axis, just make sure you label it. Yes. So axis of symmetry is there. Vertex is at 1, 1. So there's my vertex. So then now I'm going to pick another point, okay? So I've been using 1 because my axis of symmetry was at 0, but now since I'm not at 0, I'm going to plug in 0 because that causes this term to cancel, this term to cancel, so all I'm left with is this 4. So that means at 0, I have a point at 4, which also means 1 away on this side because I was 1 away to the left, 1 away to the right. So at 2, I also have a point at 4, and then just connect the dots. Any questions about that one? I'm going to do more, so I'm not stopping. I just want to make sure we're tracking at the current moment. All right. Okay, so 24. Now, I'm going to go ahead and warn you, this one's going to end up with fractions in it. If you have fractions, I don't mind you using decimals instead if you prefer that. I usually leave it as fractions because that's just me, but you're welcome to convert them to decimals if you would prefer. So 24, y is equal to negative 2x squared minus 6x plus 3. So, axis of symmetry is at minus b over 2a. So, negative b is negative 6, so that's going to be positive 6, over 2 times a is negative 2, so this is going to be a negative 4, which gives me negative 3 halves, or if you prefer it as a decimal, negative 1.5. So my axis of symmetry is that x is equal to negative 3 halves. My vertex, then, x coordinate is negative 3 halves, and then I'm going to plug it in. But now, this is probably not something you can just do in your head, so I would recommend you writing it out. So negative 2 times negative 3 halves squared minus 6 times negative 3 halves plus 3. So then this is going to be 9 over 4 times negative 2, so that's going to be negative 9 over 2. The 6 and the 2 can reduce, so that's going to be plus 9 and then plus 3. So since I need everything as over 2, unless you're going to convert it to a decimal, either way is fine. You can have negative 9 over 2 plus 18 over 2 plus 6 over 2, which is going to give me positive 15 over 2. So my y-coordinate of my vertex is at 15 over 2. So if you visually need to see it as a decimal, this is at negative 1.5 and at 7.5. Okay, so we always need to do that first before you ever even set up your graph, because otherwise you're going to probably end up having a graph that goes like way off your graph if you're not careful. So I know that I need to go up to a y value of 7.5. But what do I know about this graph?
It's going to be upside down.
Okay, it's going to open down. So, huh? Oh, it's been doing that for some reason. I don't know. So, I'm going to go up to 8 this direction. So, I'm going to go up to 8 that direction because I know it's not going up. I know my graph's opening down, so I don't need to go any higher than that. And then, I'm just going to go over a few. All right, so my axis of symmetry is at negative 1/2 and 7 halves. Or sorry, negative 1/2. The vertex is at. So axis of symmetry is here. Vertex is at 7 halves, or sorry, negative 1/2, 7 halves. 7.5, not 7/2. Words are not working for me today. So then here, instead of trying to pick, say, -1, I'm going to again use 0, which is 1.5 away from my axis of symmetry. So if I plug in 0 up here, what do I get? 3. So at 0, I have a point at 3. So that's 1.5 away on this side. So if I go 1.5 away on this side, I also have a point here.
Oh my gosh.
And then I graph it like that. Questions about that one?
When you do your, so your x is always 0, so when you graph the plots, you'll just go 3 and
Yep.
it's not x, so
X is not always 0.
not x is always 0. I mean, when you plot the y-intercept, you're just plotting, never mind, it makes sense now. I had to look at picture. Shut up.
All right, I want you to try this next one on your own, okay, to see where we're at, to see if we need to do more. If we're good, then we'll stop, but. All right, 26. F of x is equal to -6x squared minus 4x minus 5. So again, this one is going to have fractions in it. I'm going to warn you. 3 repeating.
Wait.
Wait.
You want something to be when you have when you're doing your points for vertex. Does the denominator have to be the same for both of them?
No. Because it's an X and a Y.
How would you graph that though? Like I got like the written.
Same way you would graph a whole number. I'm not getting a ruler out and measuring, as long as it's in the right general area.
Everything's down.
Alright, where's your axis of symmetry? Before we get too
Negative
far.
1/3.
X equals negative 1/3. And where's your vertex?
1/3.
Oh, negative
I have
7.
1/6,
Oh,
comma,
wait.
negative
Oh, wait.
10 over 3.
Negative 1/3, negative 7. So
What?
Negative 1/3, 5%.
It should be negative 1/3 and negative 13 over 3. Or negative 4 1/3.
Yeah, I have all this wrong.
You got negative 1/3, but I don't know how. We got 7.
Alright, so when you plugged in negative 1/3 for X, negative 1/3 squared would be positive 1/9. The 6 and the 9 will reduce to 2 over 3. So that's negative 2 over 3 because 6 was negative. Then negative 4 times negative 1/3 would be positive 4 over 3.
Oh, that's where I'm.
And then the 5 minus 5 to get a common denominator, I did it over 3. So it would be negative 15 over 3, which would end up as negative 13 over 3.
I just entire problem wrong.
Speak on it. Speak on it.
My bad.
What? 1/3. Would it be positive 2 over 3?
No.
You didn't put the negative in the parentheses.
Oh.
But it doesn't really matter because the negative 1/3 squared is going to become positive. And then a positive times a negative is negative.
Yes, you had to put the negative in the parentheses. I got negative 2.
I did. Yeah.
Keep getting positive 2, 3.
It should be negative, yeah.
I know I keep getting positive 2.
Because look, it's not in the parentheses.
I know, but I don't know why I keep doing it.
I don't know. I don't know what to say. I was close.
Alright, so do y'all need to see another one, want to see another one, or would you rather just start working?
I think I got it.
I got it.
What does everybody else got?
I got it.
Aya, you get it? Please just say yes.
I got it.
Oh, you got it? Figured it out?
You can do it too. Then.
Or you can start working tomorrow. I can do one on the board again before. So I'm gonna, because 2 of you are gonna be gone like pretty much all night long, and we only have like 10 minutes left. I'm gonna give you tomorrow to work on these as well. So if as you're going through them, then tomorrow you have questions, we can stop and answer them, or I can work another one at the beginning to make sure we're good.
I'm ready.
I'm just scared of you. I don't
What
wanna
was
lose
your
again.
actual game? I think that's
Not
late.
true. What does that mean?
Because y'all play with the like.
What does that mean?
What?
The receive and serve.
That's
That would be awesome.
what the
That would be
rotation
all
is.
That'd
Huh?
be great.
Wouldn't a 30-minute game be great?
Yeah.
That means you really
You
whoop
just
their
get like a
butts.
point every 30 seconds.
When you whoop their butts.
Just ace every single point.
You whoop their
Every single
behind.
one. Don't even give them a chance.
Whoop their behind. Oh wait, so we messed up the freaking